Howdy, everybody. Hope you're doing well wherever, whenever you are. We are here for day 3, Spiral Memory of Advent to Code. And we're just doing some more Advent to Codes from previous years to keep ourselves in the know and, keep growing, learning. Last couple days haven't been too bad. Usually the first, it depends on the year, but like usually the first week or so fall in like the easy category, the second week in like the medium, and then like the third in the hard. It's generally how it goes, but it's different, and it's different for everyone too, right? So for some people that are newer to programming, all of these are hard. For some people that have been doing these for years, right? Like sometimes I watch speed solvers. They do some of the ones that take me hours in like 5 minutes. So we're all in different places, but generally, like speaking, like if you were to look at like the quote unquote leak code difficulties, that's kind of how it falls. So hopefully these days aren't too crazy. Let's just get to it. You come across an experimental new kind of memory stored on an infinite two-dimensional grid. Each square on the grid is allocated in a spiral pattern starting at a location marked 1 and then counting up while spiraling outward. For example, the first few squares are allocated like this. Counting up while spiraling outward. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, so it's a spiral like this. Okay. While this is very space efficient, no squares are skipped. Requested data must be carried back to square 1. The location of the only access port for this memory system by programs that can only move up, down, left, or right. They always have to take the shortest path. The Manhattan distance, okay. We've talked about that before, right? Like taxi cab distance. You can either go up, down, left, or right. No diagonals. And so it's different than like the Euclidean distance. For example, data from square 1 is carried 0 steps, right? It's already there. Data from 12 is 3 steps, right? 1, 2, 3, yep. 23 is only 1, 2 steps. Okay. How many steps are required to carry the data from the square identified in your puzzle input all the way to the access port? Your puzzle input. Okay, we just have a very large number, by the way. What is this day? Holy cow. I guess I could still do this. We just return a usize. Input trim parse size. Let's do like a somewhat complex one. $31 is what it said, right? Okay. Sorry, I'm kind of doing all this busy work because I can't even, like, I'm trying to think. I mean, 361,000 is not a lot. It is a lot, but it's not like billions, right? So there is a potential to like just run through this and just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all keep going around, and you just track like your current position and like where you're at, and kind of like keep growing as you need to, going left and right. There's some other like mathematical way to do this. Hmm. I regret saying that these are easy days. This doesn't feel very easy. Again, you probably just step through it. Let's see. Maybe we look for patterns. Okay. Yeah, I mean, let's start trying to solve it. Patterns. I'm tempted to open this thing up here and play with it a little bit. Let's create a new one. Kind of want to take a screenshot of this. And paste it here. We can kind of play with it a little bit. I mean, we can start to expand it, right? So 24 and 25. That would be 26, 27, 8, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. Is this even helping? 45, 46, 47. Oh, wait. Did I do that right? 26, 27, 28, 29, 30, 31, 2, 3, 4, 5, 6. I didn't do it right, man. 37, 38. Nope. 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. And then it goes 50 right here, and then 51. Oops. I mean, I don't know. 51. Are there any patterns here? 2. So the difference between these is 2, 10, 20, 18. I don't know. Maybe it helps to think about more of like where the circle completes, right? So this one is on its own. Yeah, yeah, it completes over here, right? It doesn't actually complete over here. Like this is it's going this way. So the completion of like each circle is maybe the way to think about it is here, 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 here. Oh, those are perfect squares, right? 1, 3, 5, 7 squared. Okay, I mean that is a pattern. What does that get you? I mean, it does tell me there's some value n squared and m squared, and we know our input is between those. We'll just call it I. No, other way around. Right? I mean, that does tell you what radius it's on, right? Like, let's say the number, what was one of the examples they gave us? This one's too large. This one's base case. We may have to do the math on we may have to solve the base case on its own. 12. And 23. So if we want to try and solve 12 and 23, how do those numbers like relate to these? Interestingly, they're both on this outer edge, right? Okay, there is one thing, like the Manhattan distance, right? I'm really gonna butcher drawing this. How do I show this? Let's say we have like a grid like this. It's just a 3x3 grid, right? There's a couple ways to traverse it, right? Like, let's say we want to go from here to here. You can go da 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 da, right? Or you can just go da 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 da, or you can go da 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 da. And all of these, if you track them, 1 2 3 4, 1 2 3 4, 1 2 3 4, and there's all kinds of multitudes, but the distance is actually 4. So we don't actually have to know like the exact path we take. We just need to know like how to get there. And so like this one is kind of interesting because this one is kind of in a midpoint. And what it infers is like, oh, if you're in the middle, you just go straight up or straight down. Same right here, right? You just go this way and then you just go this way. So if you know what, like, I don't know, radius you are of the sphere, how do you calculate the radius here? What is this? 1 3 5 7. Like if we say this is V and this is R, the radius here is 0, 1, 2, 3, right? 0, 1, the distance is 1, 2, 3. What is that? It's like -1, -2, -3, -4. What is that saying? There's like a... I mean, it's definitely a series. Okay, so like here's the thought process I'm going through. We do know what these values are. Am I overthinking this? Should I just be counting? I don't know. Who knows? This feels much harder than a normal day 3. So, I mean, what do you do? And I'm probably just missing something. You're probably screaming, well, like, why are you doing all of this? Sorry. We've definitely found a pattern here. which is it's the squares of the odds. And the radius is like this value minus how many we stepped. It's like n. So you're doing like minus n. It's not this n though, right here, right? So let's get rid of that. And the reason why I'm interested in that is if we know what the radius is, we know the distance from like these midpoints, right? Like I was saying here, these going like this is the same as just going on the edge. And so like if we're looking for 12, for example, we just have to get 12 to here, and then we know the rest of it is this. And the same goes for like 9, for example. We just have to get 9 to 8. And then once we do that, we just step up. So we know that's 2. This one is already at a midpoint. So we know its distance is 0 to the midpoint right here. And so we can just go up, right? We just go up 1, 2. Is that right? 23 is 2 and 12 is 1, 2, 3. 23 is 2 and 12 is 3. Yeah. Okay, so I think we're making progress here. We just have to kind of figure out how to calculate these then. Ooh, we need to know what the midpoints are. That's interesting. Like you have, we know, let's take this 25 for example. We know 25 is like the corner, and we know like the midpoints are 23, 19, 15, and 11. That is this one right here, right? Let's see. We know that 1, 2, 3, 4. 1, 2, 3, 4, 5. We know the distance is 5. I'm gonna do an off by 1 error. I know this because it's like the distance is 5, but it's like 25 to 21, right? So it's like 5 minus 1. And each of these are 5, right? So we know like the oh, this is the offset. It's this value right here is the offset. Minus 2, right? So so it's the calculation we would do is like 5 divided by 2, which is 2, right? This is like the integer one. The integer 5 divided by 2 is 2. And so then we do 25 minus 2. And then we do 25 minus 5 minus 2. Is that right? No, it's not. It's 25 minus 5 minus 1 because it's going to go to 21. And then it's 25 minus 8 minus 2. Yep, that's right. And then 25 minus 12 minus 2. Okay. So we do have a formula for that. So what are the steps? We want to figure out which like radius which radius we're on. So we're going to go as long as we're less than or equal to, counting by 2s. And then we're going to track this value right here. So what is the radius? So we'll have 5 and 2. I'm just trying to think, is this 2 related to here? No, it's not. It's the distance between these, right? Because so if we're doing 49, it's 7 divided by 2 is 3. So 1, 2, 3. And then we're going to do 7 minus 1 is 6. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3. Yeah. And then we just go another 6. 1, 2, 3, 4, 5, 6. Yeah, so this it's always divided by 2, and then we subtract this value minus 1. Okay. We also need to find which one. Oh, we can do the midpoint pretty easy. We need to find which one it's closest to, but we just like can calculate the 4 midpoints and say what is the minimum distance among them all. I think. Okay. We call it V here, right? Mute V equal 1. While V times V is less than input. V plus equal 2. Is that right? So now we know what our V is. Okay. Oh, we also want to track our R. Oops. Is that right? I think we just track it, right? Because this is going to be our radius. So each time we step, we have a new radius. So this is our R. And this is our V. Okay. So now we need to do this math over here. So we're going to say let what were they? The midpoints equals V times V. What is this value? The dist? V times V minus V divided by 2 for the first one. I think that's right. And then the next one's going to be V times V minus V divided by 2 minus the offset, which is V minus 1. And then it's times 2 and times 3. think that's right. Doesn't like here. Oh, it's just assigned but never read. Okay, I think we'll use it later, right? Yes, because so now we have these midpoints and we want to say let nearest equal midpoints.iter.map m it's like input minus m.abs. Oh no, input we're using usizes, so it's input.abs diff m dot min unwrap, and then it's just nearest r plus nearest dereference panicked. Test 1 was okay, test 2 was not. I mean, it does solve this one, right? Should we do one of the other ones? Oh, one is an interesting case, although I'll never get the actual one case. Math still mathing. And 12 was 2. And 23 was 3. No. 12 was 3, 23 was 2. It was the other way around. Okay. I mean, that I think we did it. Rage? Yes. Okay. That felt harder. That felt a lot harder. I mean, look, I had to figure all this stuff out. Is there an easier way to do it? I think you might be able to, again, just go through all 361,000s. It feels like it might be harder, though, to like, how do you know when you've reached the edge? Oh, you might be able to, like, you start at 1, and you always know you go right 1, and then your distance is 1, 2, 3, 4, 5, 6, 7. I don't know. We may have. It's a. Who knows? Very. I mean, I think we found a good solution to it, right? This is a more analytical approach to it. We use some math to say, oh, we can actually do some stuff. We just need to figure out what V and R are. I mean, I just picked random variables. They're probably not helpful. The R is like was what I was thinking was the radius, and like the V is like the value of the value squared, right? Or V squared. And then we just had to find these midpoints. I could probably use variables here to help it, but essentially the first midpoint is just like, again, like V squared, so like 25 minus V divided by 2. And then the rest of them are that same thing, but you need to subtract like the distance you traversed, which we figured out was V minus 1 right here, and then the number of times that you've done it. So initially we just go this way, and then we offset this is like an offset, I guess, right? We're offsetting ourselves to like from here to here, and then to here, and then to here. That one was mad though, right? Okay. Part 2. Did I do that right? Yeah. Okay. Part 2. As a stress test on the system, the programs here clear the grid and then store the value 1 in square 1. Then in the same allocation order as above, they store the sum of the values in all adjacent squares, including diagonals. So the first few square values are chosen as follows. Square 1 starts with the value 1. Square 2 only has one adjacent filled square, so it stores 1. Square 3 has both values of 1 and 2. Wait, what? Square, this is square 3. So square 1 has a 1. It's square 2's only adjacent is 1. Oh, because these two are 1, this is 1. And then this one's 4 because it's 1, 2, 3, 4. This one's 5 because it only has 4 and 1. This one's 10 because it has 5, 4, and 1. What is the first value written that is larger than your puzzle input? Ugh. Do we want to math this one out? Um, okay, maybe we do the same thing. What a crazy day 3. So can we finish this one? What is this? 806 plus 23 plus 25. So, I mean, this is helpful in the sense that we don't have to like pre-calculate values around. We have a set of like values we've calculated, and we just have to find their surrounding ones, see if they're in there. So that does feel like we could do a like a hash map where we're just tracking which ones we've entered. Let's calculate this one though and see if there's a pattern. 806 plus 23 plus 20. Well, 23 and 25 is 50 minus 2. So this would be 854. And this one is another 50 plus 1. So it would be 905. Is that right? 125, 905. Again, well, man, the last couple days were so easy. I think we can still get there. It'll be okay. I don't see a pattern though. And I don't want to keep calculating because it feels, well, the numbers do increase quite a bit, right? Like you can imagine this number right here is very large, right? Like the question is like, what is this value? We know it's at least 1700, what, right? 1759 plus whatever this number is, which we know is at least 1600. So this one's like, it's definitely growing like exponentially this way, right? I was gonna say these are our endpoints in the spiral still. So like whatever this value is, again, I don't want to calculate it. It's the largest in the spiral, but they are growing very large. Like the thing that I'm wondering is how do you how would you traverse it? I was saying in part 1, we could just traverse it, but we could try the puzzle way. Are there any more patterns? The thing that's going through my mind is it doesn't feel like there's a pattern, and it could just be my math isn't mathy enough. And the reason why it doesn't feel like there's a pattern, because it has to do with like values you've seen before, right? The previous solution was, I mean, I guess it was still a little bit that way, but it was kind of irrespective. Is like you just kind of found what radius you were in, and then what this corner value was, and you could spill that. But there's no 15147. Like the problem I run into is like it's pretty easy to see 1 9 25 49. You're like, oh, those are primes of the odd numbers. Or not primes, those are squares of 1 3 5 and 7, right? I just don't know what 147 is. I mean, I know what 125 is. What the heck is 905? Should I pull out my calculator? The square root of 905 is 30.08. I mean, that's not really helpful. I mean, 900 is 30. Is that a pattern? I mean, not really. Like this could be 30 squared plus 5. And then this is like 5 squared plus 0. And then this is 0 squared plus 0. I mean, there is this. Oh man, I really don't want to calculate. There's like this chain right here. This can't be a day 3, right? Spiral memory. This is some epic pattern matching if there's a... Like, I feel like I got this pretty fast. Again, though, I think you could kind of figure out... Okay, let's think about like how the traversal works. Like, we want to step... Let's ignore from here to here for now. Let's think about, like, we're right here. We want to step 1. Then we want to step 3, right? 1, 2, actually, okay. We want to step 2, like the distance from here to here is 2. And then from here to here is 2. And from here to here is 2. And then we like step 1. Yeah, we step 1 to get over here. It's actually different. We step 1 and then we go 2 more. We step 1, we step 2, we step 2 more, and now we step 1, 2, 3, 4 more. What? And then we step 3? And then we step 1, 2, 3, 1, 4. And then we step 4. And then we step 1, 2, 5. 1, 2, 2, 4. 3, 4, 4, 5. So it's like the pattern there is 1, 2, 2, 4. 3, 4, 4, 5. And I presume this one's going to be 5, right? Because we're going to be, yeah, we're right here technically. 1, 2, 3, 4, 5. So it is 5. And then what is this? 1, 2, 3, 4, 5, 6. 6, 6. 7. Okay, so there is some kind of pattern emerging here. It's like this is moving up 1, left 2, down 2, right 4. So whenever we go left, if we're going left, if our new direction is left, I should say, if our new direction is left, we increment 1. I'm not seeing the link here. Do I have these numbers wrong? 1, 2, 3, 4. Okay, so we go up 1, and we go over 1, 2, and 1, 2, and 1, 2, 3. Like the question is like the way I'm thinking is like we have some direction, right? We have up, left, down, right. And we're going to say we want to do this n number of times, right? So it's going to be, we want to do it 1, then 2, then 2, then 4, apparently. Is that right? No, 1, 2, 3. It's not 4, it's 3. Okay, so that's where I was confused. I couldn't find what that is. It's 3. 3. And then we go, yeah, so this one right here is 3. Right? Because I'm right here and I go 1, 2, 3. Then I'm gonna go 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4. 1, 1, 2, 3, 4, 5. Yeah. Okay, so this is the pattern. So whenever our direction is up, we plus 1. Let me do that in a color. We plus 1. And whenever our direction is right, we plus 1. Oh, no. It's whenever it's left, we plus 1, and right, we plus 1. Is that right? And we're always going to go in this order. We're going to go up, then left, then down, then right, and then up again, left, down, right, up. Yeah. Okay. Hold on a second. I'm going to pause it. Well, I can't pause it. I'll be back in 1 second. Okay, sorry. I should probably find some way to pause. I think I've said this before, but I kind of keep track of all my stuff over here on this screen. I guess you can't see it. But I haven't really figured out how to get it to pause well. And I didn't expect this to take. We're at 50 minutes. The irony is I was going and helping someone. It was, I think if I had figured this out in part 1, part 2 would have been just as easy, which is kind of funny. I probably should have just done it this way to begin with, because I could have just done this logic 500,000 times or whatever and would have been done, right? But I do think we have this now, right? Is like the idea is we'll say our current position is here, and we know this value is 1 and this value is 1. And then we'll just slowly go up. We'll have like directions. We'll say, okay, our n is currently 1, and so we'll go up 1. The next one is left, so we'll go left. Left changes it, so we increment it to 2. So we go left 2, then we go down 2. And each time we hit one of these, we just consult our hash map and say, which of the surrounding neighbors do we have? And there's 8 of them, I guess. Okay. and just we increment when we hit left and right. And then I've spent so much time doing this. What is the first written value that is larger than the puzzle input? So we're going to keep going until we find a value that's larger than this. Okay, I want to start working on this. Let's just start. Don't even know how I test this. What was going through my mind? But we have like, I mean, maybe we just ignore the test. Or we can figure, I mean, we'll figure out what it is. Well, 806. Maybe we do 800 and we know it's 806. Is that right? Yeah. Okay. So we have our input, and we're gonna say let mute scene equals fx hash map default scene dot insert. So 0 0 is 1, 0 1 is 1, and we'll say let mute let cxcy equals 0 0 1. So we're going to start at this position, and we know our let mute steps equals 1. We're going to start at 1. And so we need to do our directions. So up is, ooh, do I have these in the wrong way? Like this is x1, y0, x1, y0, x1, y0. So up is 0, 1. Down, no, we're going up, left, down, right. Left is 0, negative 1. Down is 0, 1. No, negative 1. Up, left, down, right. Okay. This one doesn't have to be mutable, right? Sorry, I keep checking stuff because I wasn't expecting to be this long, and people have expectations of, so I need to figure this out. Okay, I think we want to do it just like each thing at a time. So we'll have like a loop, and then we'll have a for dx dy in directions, and we'll do some mathy math here. And there's going to be something where we say like let cur equal, it's going to be like for 0 dot dot steps, and then do do the logic. Yeah, so we're going to do some logic, and we're going to say like let cur equals whatever 0, and we'll say like if cur greater than or equal to input return cur, like that. It's gonna look. I mean, this is not the right answer, right? This it's still broken, but I think that's generally the idea of what. So this part's gonna be like calculate. Do I need to enumerate these? So it's like I dx dy. Oops. In directions dot iter dot enumerate. And then we say like, what is it? 1 and 3. If I equals 1, I equals 3. Steps equals 1, right? So this is the we step longer in the directions left and right. One, 1, 2, 1, 2. Okay, we go 1, 2, 3, 4. It just doesn't seem very intuitive, so that's why I have to keep checking. No one actually wants to keep their data in a spiral grid after this. Oh, this has to be mutable as 2. Here. So we say cx is plus equals dx, cy plus equals dy. All right. And then we just need to calculate the values and then insert it. So we're saying dot insert cx, cy, or like this. So now we just need to calculate the surrounding ones. It's just that. So I have to do this and this. And what doesn't it like here? Consider borrowing. Oh, I know where that ampersand is, I promise. Why doesn't this ever finish? X and Y is 1 and 0. Let's see what's breaking here. Print line. CX. CY. So my math isn't mathing. Our cur is at x1, y0. Our steps are 1. Our directions are up. No. Yes, up, down. Ooh, do I have my directions wrong? That's down. Up, left would be -1, 0. Up, left, down. It's always returning the answer of 1. Cur is always 1. Maybe let's not do the solution for now. So we move to our next position. So the 0, 1. Let's just like after the first step, let's return this. 1, 1, 1. I mean, that's definitely not right, right? We are at 1, 1, but its value should be 2. So it feels like it's this part right here. -1 to 1. Cartesian product of. What am I doing? Am I doing this wrong? Range inclusive. You give it 2 range inclusives. -1 to 1. I mean, I guess I don't have to do this. I mean, I shouldn't change. Oh, wait. That actually does fix it. Why does that fix it? Oh, no, I'm an idiot. I was filtering where... Yeah. This actually doesn't have to be here. So my mistake was I'm only picking where it's like the center point, which is incorrect. Like the Cartesian product is going to give you like the 9x9 grid, and I don't want the center one, right? So what I really wanted to say here is not, not, and not. Does that give me the right answer? 110. I actually don't think I need a filter because it shouldn't find the middle one. I'm doing something wrong. I think this is right now. So if I do this, presumably I get the right... Nope. It's still going on forever. So what do we do? I mean, do I just... I can calculate it manually. Why isn't that still working though? Do I have these ones correct? So the center is a 1. Right? And then 1, 0 is a 1. X equals 1. 0 equals 1. X, 1. And we're going to start at 1, 0. We're going to step. So I mean, I can just do it like this, like for x in -1 dot equal 1, right? Then for y in -1 dot equal 1, if x equals 0 and y equals 0. This is what I was trying to do with that filter, right? We don't want to test this case. It actually shouldn't be in our hash map, so it should return 0, but we just do cur plus equals scene.get xy dot unwrap for 0. Does that like suddenly fix it? Doesn't appear so. So is my stepping wrong? Let's just do one loop. And see what we get. 1, 1, 0, 1. Okay, so we're at 0, 1. We go to 1, 1, which is correct. But now we'd want to go to 1. No. We're at 1, 1. We're here. We go up to 1, 1. Now we go 0, 1. -1, 1. 1, 2, 4, 8, 16. Okay, let's just try our x's and y. Negative 1, 1, negative 1, 0, negative 1, negative 1. Okay, and then let's do 2 of them. Our numbers are wrong. Like, how do I possibly get 8 here? Do I need to calculate and then move? No, I think I move and then calculate, right? Like, because these first ones are right. No, they're not right. This one should be 2. Like, I'm at 0. I'm doing something wrong. This is 0, 0. This is 1, 0. Okay. So I'm at 1, 0. Correct. And I know that value is a 1. And my step is 1, right? Yeah, I'm going to step 1. And I'm going to go up 1. So I get 1, 1. So I know this is 1, 1, which is correct. But why do I only get 1 from the map? Okay, let's try this. Print line. I have to do it like this. Zero, 1. One, 2, 3, 4, 5, 6, 7, 8. These. Something's not right. Oh, it's that. Yeah, so I'm almost positive this actually works. These are deltas, so cx plus that and cy plus that. Oh man. Does it still solve? Yeah. Ooh, but it's taking Oh, I didn't have a part 2. I was like, wow, it's taking very long to solve. Is that right? Okay. Let's see. 36. I mean, it is larger. That is the right answer. Oh, what a bug. What a bug. Okay, we did get there though. So just to be clear, what was the bug? You were probably yelling it at the screen. When I was doing this calculation, I was just calculating these values, which is like the inner square. And so that's why it was never changing. The actual inner square, what I wanted to do was the square around this. Normally I create like a neighbors, I have like a point and I have like give me the neighbors, and like that makes it easier to do that. So that just messed me up. Bugger. Okay, but I think we got there. Okay, so what about this day? I don't know. At least for me, this felt way harder than the first 2 days. Maybe this logic isn't that difficult. It felt more difficult to me. Let me know if I did it wrong. I would love to know if you have a better solution for this. It's quite possible that I just was like missing the boat. But I definitely went for like is there like an analytical way to solve this in part 1? And then part 2 is just like, I don't think there's a pattern, so I think I just have to like follow the series. I think I got there okay, right? Like eventually we got there. And then I just had, it's just this bug had me off, right? Is when I'm calculating the value for my hash map, I wasn't using my current position plus the offsets. And so that messed me up. But again, like, so what, at a high level, what are these? For part 1, we kind of went through these are squares of the odds. And so I can just keep counting that until I get that value. And then I just keep track of that radius, and that I just started at 0 and then it's 1, 2, 3. So I'm just incrementing. So that's what this part is right here. The radius is +1 and this is +2. So now it occurs to me you could do like half -1 or something like that anyway. Oh, maybe not. 7, 6, 2, 3. Yeah, it is. I could have calculated R from V. It's like V -1 divided by 2, right? Anyway, I still got that. But then we just find the midpoints of each of those sections, and then we just need to find out what's our minimum distance to one of the midpoints. And now we know it's just the radius to get us up to that like, you know, that part of the spiral, and then the distance from that midpoint. And then for part 2, we said, I don't think there's a pattern, so we got to calculate, or we just got to keep walking through the loop. And it turned out not to be too hard, 6 microseconds, right? Oops, this thing's stuck here. Which there's a little effort because you have to figure out when do you increment your stepping, right? We know where we start, and then we know our directions, and then we just need to know when we're incrementing, and it's when the directions are left and right. Is that correct? Yeah, it is. I guess that makes sense, is because when you're going this way or this way is when you're like, you've got like a new set of things that you need to go through. But then we just iterate through each of those steps, do the increment by our deltas, calculate the things, again, remembering to do our additions right here. And this gives us our value at that position with the values we've seen before. And we say, oh, did we ever get to that point? And if we have, we return it. Otherwise, we insert it and keep doing that. I do think this loop in 4 is probably the why you could potentially... it's a little hard to figure out when you're at step 1 and step 3 of these directions. you could potentially have another value here that says like how much do you increment the step by, and then you don't have to loop, you just for through it. Like I can show you what it would look like. It'd be like 0, 1, 0, 1, and then it would just be their cycle, and then we'd have dx dy step, and we do steps plus step like that. We have an extra one now. I think. What doesn't it like here? I think I have to do this, but it still does give me the right answer. There you go. So this is another way. Then you don't have double loops, I guess. You're just cycling through these directions and how many you should step. This way feels a little bit more readable, right? We can say I'll leave it at this. This is my original solution. I'll leave it. I'd love to see your solutions, though. Let me know how you solved it. I'm definitely interested in this one because for a day 3, it seems harder than normal. And so I would expect maybe I missed something. And so if there's something I missed, I would love to hear it from you. So send me those notes or send me your solutions. I'd love to see that. And again, I think it's potentially possible to, again, it only takes like to calculate the values. I was able to get there like in 5 milliseconds for or microseconds, I should say. So you could probably, if you had done this in part 1, part 2 is probably easier because you just like take what you've done here and do it in HashMap. So doing the analytical way for this day actually may not have been like the best way to do it, although it's technically faster, right? You can see I solve it in nanoseconds as opposed to microseconds. But if you'd done it like the quote unquote like naive way of stepping through the whole thing in part 1, that would have made part 2 much easier. I kind of had to like figure out the problem twice. And so sometimes, I don't know, I probably should have just done this first and then figured it out. But there you go. We solved it. We got it done. Thanks everybody. And we'll talk to you next time. Bye.